Lewis here. I'm recording my last video of the day before my voice completely quits out. But this one is for you this week on this coming Thursday. You probably can already tell I'm going to have to record these videos for future classes because I can't leave them like this. It's bad. But I'm going to go through this one as well with you. Circles. I'm not going to tell you to pause the video. Okay, you pause it when you need to pause it. But I am going to try to go through this quickly in lieu of my voice. Okay, and again, I am sorry. All right, so a circle is a round figure whose boundary consists of points equal distance from a fixed point. What does that mean? It means that if I have a point right here and I start making points that are equal distance, this from here to here, from here to here, all of these points are same distance around. Well, that's what it's saying. And what did I make? I made a circle, okay? That's all it is. And on a circle, there can be an infinite number of points, but we usually just kind of make a line around it. All right, so this right here is equal distance from here to here as it is from here to here. All right, that's all that's talking about. All right, another definition. The center is the center of the circle. Well, that makes sense. And if you can't understand that the center of the center is the center, I don't know what's wrong with you. All right, radius. It is the distance from the boundary to the center of the circle. Well, we already kind of drew some of this. You have the center of the circle going to the boundary. That's what the radius is. It's from the center to the boundary. Diameter. It is the distance between 2 points on a circle through the center. Okay, sorry, I didn't mean to mess that up. It's the distance between 2 points on a circle through the center. Well, what does that look like? Going back to my little drawing right here, it looks like this. It's going from one point through the center to another point. That's all that is. Now, that gives us a kind of an equation. It gives us diameter is equal to 2 times radius. So diameter equals twice the radius. Last definition is the circumference. It is the boundary or perimeter. Basically, it's outside of the circle, okay, of a circle. It is calculated by the following equations. Circumference equals pi times diameter, or circumference equals pi times radius. Well, your biggest question that I have a lot, and I'm not going to do it for the sake of time. I'll try to do this in class. I want to tell you how we get pi. Pi has actually got a very interesting story. So next time we're in class, somebody asked me about pi and where's it come from. But for now, and for the sake of this video, pi can be considered one of two things. Pi is equal to 3.14. This is what most of you know. However, this is not accurate. Pi is actually 3.14 in an infinite number. So if I was able to put pi into my calculator, and I don't know, I'll try to get this where you can see it, and hit enter, notice how it's an even bigger number than one, a longer number. It is a bigger number, but a longer number. Well, this isn't even accurate. This has even been rounded. All right, so my biggest thing that you need to understand is pi is a number that never ends. We've never found it, and that's as far as I need to take it. So in this video, you're either going to see me say use 3.14 for pi, or you're going to see me say use the pi key. This is a big distinction. Notice the difference between pi 3.14 and the pi key, which is this right here. If you use 3.14 on a problem when you were supposed to use this, your answer might come out wrong. So make sure you read the instructions. If it tells you you use the pi key and you use this, your problem's going to come out wrong. So be very careful. All right, enough preaching about pi, but I do want to tell y'all the history of that in class. It's kind of interesting. All right, so some basic examples. I want to find the circumference of the diameter if the diameter is 2 meters. So I know circumference equals pi times diameter. I plug in my 2. Circumference equals pi times diameter. When I did, in this case, I used my calculator. I rounded to the nearest tenth. I got that my circumference is equal to approximately 6.3 meters. Look at this one. Find circumference if the radius, notice the difference. The first question was diameter, this one is radius. This is radius of 10.5. Well, my equation for circumference is circumference equals 2 pi times radius, or 10.5. And when we work that out, we get approximately 66.0 feet, 66.0 feet. Right, now again I rounded this one for you. I just want you to see it. Now you can put this in your calculator if you want, and you can see the difference between what this is and how I rounded it. Alright, now one of the big things about circles and knowing how to find area. Area is a big equation, so area is a major equation, because this is another one of those equations. Like I told you in the last video about Pythagorean theorem, you will see a lot in your life. This is another one. So area is equal to pi r squared. Alright, so in these examples I say that I use the pi key and I round it to the nearest tenth. Alright, so if a circle's radius is 5 inches, find the area. Alright, so look at what I did. I said area is equal pi times r squared. I plugged in my 5 in the place of r, and I said that 5 squared is equal to 25. So my area is equal to pi times 25. I plugged this into the calculator, and I'll just show you what I did. I said 25, and then if you don't know where the pi key is on your calculator, if you have a TI-84, you hit the second button, and you see this carrot top button, or a house top, or rooftop, whatever you want to call it, you hit that. And now you got your pi key in there. So I'm going to put pi times 25. I hit enter and I get this long number, but I don't want that, so I round it to the nearest tenth. And I got 78.5. Now, since this was area, my answer should be 78.5 inches square. Alright, so don't forget that. Don't just give me a number, always give me the proper unit, inches square. Alright, so number 2, it says, if a circle's diameter is 8 centimeters, find the area. Look at what it says, circle's diameter. Alright, well, we need to remember something, and I'll hide some things, that the equation is area is equal to pi r squared, r being radius, but the problem gave us diameter, so we need to be able to go from diameter to radius. Well, that's what this equation was on the first sheet. Diameter is equal to 2 times radius. Well, what was my diameter? My diameter was 8, and so I can find my radius now. That means that my radius is 4. Now that I know my radius, I can plug it back into this equation and solve. Excuse me. Area equals pi times radius squared. Plug in my 4, and I get pi times 4 squared. Pi times 16, because 4 squared is 16. Multiply this out, and I get 50.3 centimeters square. And I'll round it to the nearest tenth again. Alright, number 3 is a little bit different. I don't want you to look at it. It says, if a circle's area is 314 meters square, find the diameter, radius, and circumference. And this time it tells me to round to the nearest whole, and then notice I forgot to put this in on your notes. It should say as needed. Alright, so what's happening here before I start showing you anything? It tells me the area. Oh, everything else I've been looking for the area in my first 2 problems, but this time I've got the area, and I'm having to work backwards to get diameter, radius, and circumference. Alright, so what do I need to know? Well, let me slide this up and keep things somewhat organized. I need to remember this. Area is equal to pi r squared. Well, if I know the area, I can manipulate this equation to solve for r. And when I know r, I can use that to find my diameter, that shouldn't say pi, guys. That should say 2. Wow, I really am sick. That should say 2. So diameter is equal to 2 times the radius. All right. Once I know that, I can find my circumference. But circumference equals pi times diameter. All right. So let's work with this equation first. So this is what we have. I have area is equal to pi r squared. I plug in my area, which is 314. So 314 is equal to pi times r squared. So what did I do? I went and used the pi key. I said 314, and I divided by pi. Well, why am I dividing pi? You need to treat pi like it's a number. If this was the number 3, you would divide by 3 on both sides because you know you're trying to get r by itself. So we treat pi just like a normal number, and we're going to get rid of it by dividing. So dividing by pi, and I get this number, 99.99. Well, my problem told me to round to the nearest whole as needed. When I do, I get 100. So 100 is approximately, r squared is approximately 100. Knowing this, to get rid of my r squared, I have to square root both sides. And when I do, I get that 10 is equal to my r. So r is a radius of 10 meters. All right. Now, I just looked at it a while ago. This is just how tired I am. My diameter, I put the wrong equation over here. This should say 2r. It's 2 times r. This should say 2 times r. Sorry about that. So diameter is 2 times r. Well, diameter is equal to 2 times 10. And when I do that, that is not going to be 31. That's going to be 20. So my answer for this is 20 meters. I'm glad I caught that in the video while I was recording. Now that I know that this is 20 meters, I can plug it into my last one. Circumference is equal to pi times diameter. Well, I plug in 20 this time, so it's going to be pi times 20. And when I do, I'm going to say 20 times pi, and I get 62.83, but I want to round it to the nearest whole, and I get 63. So my final answer for this thing was 63. What is this in meters? 63 meters. All right. Hey, this goes to show you that this really does prove a point about something I really want y'all to start doing, is double checking your work. Look how easy it was for me just to mistake. I mean, I've worked with this equation all my life, and even I've done this since probably when I was 10 years old. I make mistakes too, okay? So always go back and double check your work. And I'm glad that I caught this now, because it really does kind of show you that we're human and we goof up and we make mistakes, and that's okay, as long as we remember to double check ourselves and we catch them. All right. Now things get complicated. That's the easy stuff. Most of you know how to do that. So I'm going to start over here. And I'll cover things up with my hand to the best of my ability. I'll do this so we don't get too confused on things. So I have a shape here, and my job is to find the area of this shape. And my instructions told me to round to the nearest tenth as, round to nearest thousandths as needed. This is not on your notes, but make sure that you understand that we're going to round to the nearest thousandths as needed. All right, so we're going to cover this up so we can kind of keep track of things. All right, so we're going to find the area of this shape. Well, this is very similar to our triangle problem, where it looked like a giant triangle and a triangle was cut out of it. It's very similar. I have a big circle with a small circle cut out of it. Basically, I have a donut or a ring or whatever. So the same principle applies, just like in the last video. I'm going to take the area of my big circle, I'm going to find it, and then I'm going to find the area of my small circle, and I'm going to subtract. Well, I'm going to work this all the way out. My area of my big circle It says pi r squared. Well, how do I find r? Well, my big circle, the diameter of the big circle from here to here is 9. Well, how do I change this to radius? I divide it by 2. So my radius is 4.5, which is what I have here. So pi times 4.5 squared, work all that out, and I get approximately 63.617. Now I need to find the area of the small circle. Well, from here to here is 7.5. That's the diameter of the small circle. So divide that by 2, and you get the area of the small circle, the radius of the small circle is 3.75. Plug that into your equation, and you get pi is equal, pi times 3.75 square. Wow. Pi times 3.75 square is equal to 44.179. When you know these two, you subtract, and you get your final answer of 19.438 inches square. Now I could tell, don't remember, I generally don't round often. I like to do, I think I've said this before, always wait till the end to round. But in this particular case, because we got those really weird numbers, it was okay to round because the instructions allowed us to do so. Alright, so this next one, it's not a very good picture, but this right here is a half a circle. Well, how do you find half a circle? Well, think this through. If you know the area of an entire circle, a big circle, all you got to do is divide it by 2, and you know the area of half a circle. So that's what you're doing in this problem. You find the area of the circle, if it existed, and you divide it by 2 because this is a half a circle. Well, we know that this right here is our diameter, so we need the radius. 9.5 divided by 2. When we do, we get, actually, and I'll work it on the way down here, we get 4.75. So now I'm going to put all this in my calculator. I know that the area of the big circle, of the actual circle, is pi times 4.75 squared, and work that out, and I get 70.882. Well, since I don't want an entire circle, I only need half a circle, I divided that by 2, which you see right here, and I get a final answer of 35.441. This looks more complicated than it is. You need to understand that this is half a circle, and if it's half a circle, just find what the full circle would be and divide by 2. Now this last one, I am going to admit, is a doozy, so I'm going to move my hand a little bit. And I need to talk this one. This one looks kind of like a bullet. Alright, that's the best way I know how to describe it. And this bullet here, this bullet shape I should say, we got a couple things happening there. There's actually a total of 4 different shapes in here. And let's talk about each and one first. Where's my color one? Alright, so the first one we can find pretty easy. It's this big rectangle right here. Okay? So we have a big rectangle. That's my first one. The next shape is a small rectangle, which happens to be right here. Most people think that this shape right here is a half a circle. This time it is not, and here's how we can tell that the radius, notice that I give you the radius here, the radius is not in the middle of my shape, it's at this little edge right here. If this was a full circle, the radius would be, and I'm putting a different color here, the radius would have actually been here in the middle. Would have started at this point, but notice that the center of the circle is up here, and there's another center of a circle here. So really, these two shapes excuse me, I already said the answer. This and this are two shapes right here, okay, and this green, and we have a rectangle. So this is what we got, and I'm sorry, I'm not being very clear. We have a big rectangle, we have a little green rectangle, and we have 2 pieces of a circle here. Now, to kind of help you out, these 2 pieces are quarter circles. So this one's a quarter circle, and this one's a quarter circle. Okay, whoops, didn't mean to write that. And here's the thing, if I combine these 2 together, this quarter circle plus this quarter circle, 1/4 plus 1/4, when I add them together, I get 1/2. So together, these two shapes, I'm sorry, I ran off the screen. These two shapes make a half a circle. Okay, I'm running out of room, so half a circle. So what does that mean? It means this. I know the area, I can find the area of my big rectangle. I can find the area of my small rectangle. And instead of having to worry about two individual pieces right here and here, I can just say, hey, I can find the area of a half a circle. Hey, that's not too bad because it's the same equation we used before. But we just need to remember that there's there's a total of 3 shapes here and not just 2. There's 3, not 2. Alright, so let's work with the rectangle, the first big one. Okay, trying to keep things somewhat organized. Alright, so base times height. Well, how do we get that? Well, we know 7, there's our base, but where did I get this 18? Well, look at your picture. It's kind of hard to see probably on camera now because I've got too many colors going on. But let me write this in. You know that from here, from this point to this point is 2 inches. That also means that from here to here is 2 inches. So let me rewrite this. Alright, so that means from here to here is 2 inches. Well, if this is 2 inches and the total length is 20, that means that from here to here is actually 18 inches. That's where I get the 18 from. So from this purple box, it's 18 inches. So 7 times 18 is 126. Alright, now let's use the red one. Alright, you're already seeing the final answer, but I don't care. Alright, the green box. Well, look at it. I already kind of helped you out. You already know that this side right here, from here to here, from this point to this point is 2. So we're good on that. But our problem is we don't know from here to here. Well, we can find that out by doing a couple things. We know that the total length is 7. We know that this length is 2. We also know that this length is 2. Well, wait a minute. If we know that these two are 2, that means that this middle section is going to say 2 plus an unknown plus 2 equals 7. Well, what can I really say? I can actually rewrite that statement, and let me just kind of help you out. I can say that 2 plus some unknown plus 2 is equal to 7, right? Well, knowing that, I can really say 4 plus x is equal to 7, so x is equal to 3. So this missing length right here is actually going to be 3. So my small rectangle is going to be 3 by 2, because this length is 3 and this length is 2, based upon what we said earlier. Alright, so 3 times 2 is equal to 6. Alright, now we need to do the last piece, which is these 2 half circles. Well, look at it. You know that the radius on this one is 2, and it's the same radius as this. So if you know the radius is 2, you can simply say that the area, and I can't move my paper now, it's stuck. There it goes. My area is pi r squared, and we're going to do that, and then we're going to divide by 2. So pi times 2 squared, divide by 2. Pi times 2 squared gives me this, 12.56 divided by 2, and I get 6.283. Now that I know all 3 pieces, I know the 126, I know that's my purple box, my green box is 6, and my half circle is 6.283. Add the 3 together and I get 138.283 inches square. Now, I apologize if this wasn't very clear because my voice really is giving out. But if you got any questions on this particular one, because this is a hard one, ask me. Alright, now we've gotten down to, how many more questions? Now, we've got 3 more questions left. Now, I am going to do this first. Excuse me. It says find the length of stock needed to create the shape shown to the right. Alright, well, length of stock, and I wish I had something, basically is a piece of pipe or a piece of rebar or anything like that, where you have to take it and you have to bend it kind of like this, and you have to keep bending it until it makes the shape that you want. In this case, we're trying to make a shape. Now, I'm not going to go into all the physics of this right now. I'll try to talk to you a little bit more in class to explain it better. But when we go to measure, we're trying to find the length of this entire shape. Let me do it this way. From here to here, this is what we're looking for, is a straight piece of pipe. We've got to find that by using this picture. And the way we do that is we find the diameter based upon the center of the stock. Well, what do I mean? Notice that what we're really, let me rephrase this. What we're looking for is what we call a center diameter. This is a Mr. Lewis term, okay? This is not a mathematical term or probably even a professional term, but it's a Mr. Lewis term, the center diameter. Right now, we know two things. We know that the outer piece of this stock is 10 inches. We know that the inner diameter is 9 inches. What we're trying to figure out is the center diameter. And what do I mean by that? If I went to the center of, notice how I went right straight in the center, and I went to the center here, and I'm going to bring this out. No, should have used another color. I'm trying to find this, and I'm going to put CD in there. Alright, I'm trying to find the center diameter. I don't want 10, I don't want 9, I want what's halfway in between them. And in order to do that, I take the outer diameter, I add the inside diameter, and I divide by 2. Well, what do I simply do? Alright, so in other words, I say my outer diameter is 10, my inner diameter is 9, add them, divide by 2, and I get that my center diameter is what I need is 9.5 inches. Now that I know what the center diameter is, I can find that length of stock that I needed. Well, think this through. If I was able to bend this pin all the way around, what am I really finding? Think it through. Okay, it's making a what? It's making a circle, you understand that, but what term have we used before? It's not diameter, it's not the radius, we're not looking for area. Another way we can say length is perimeter. We're looking for, making you think before I give it to you, looking for the circumference. So we use this center diameter to find the circumference. So pi times diameter, pi times 9.5, and we get that the circumference is 29.8 inches. So what we're needing is a straight piece of stock. Well, this pin's no longer straight because I've bent it too much. A straight piece of stock that is 29.8 inches. And that when we bend it, it's going to make a circle. It's going to make a circle that has an outside diameter of 10 and an inside diameter of 9. This is a very tough question at first, because a lot of people forget this first step. You've got to find the center diameter when you're looking for length of stock. And that's the big key. How do I know when I use this equation? When you see this statement, length of stock, when you see that question being asked, you know that you're probably going to be using this equation, especially when we're dealing with circles. So if you're dealing with circles and it says length of stock, you need to find that center diameter. Alright. Alright. So let me cover this up a little bit so you can already look at it, but I want you to see what's happening. Alright, so we have a pipe here. And it says find length of stock. Okay, so right off the bat, you should be knowing and understanding that you're trying to measure to the center of the pipe, okay? And we need to create this pipe shown. So what we're going to do this time is we have this straight piece of pipe, and we're going to bend it to this shape, okay? Now, what we're trying to do is we need this shape, but we need to know the length of the straight piece before we bend it. All right, that's what's being asked. So, this one gets a little complicated, so let's start and look at the shape. First off, you need to realize that there are 3 shapes here. The first one is a straight shape, which is right here. Okay, I'll color this in. All right. Now, just because I'm coloring this in doesn't mean I'm looking for area. I'm looking for length. I'm just coloring it in so you can see the shape. So I have one shape, straight shape, and that's worth 12 centimeters. Then I have another straight side, which is right here. Okay, and that's worth 9. My last thing that I'm looking for is the curve right here. And this is where things get tricky. I need to find that curve. All right, and in order to do that, we need to measure to the center of the pipe. Well, before we try to start hurting our brains, we need to remember that in order to do that equation, it's the center, and I don't want to, and we'll talk about that in just a second. It's the outside plus the outside diameter plus the inside diameter divided by 2. Well, look at it. I didn't give you the diameter. I gave you the radius. So from the inside, from here to here, this is your inside curve. This is only 8. All right? So I don't show you an outside either. But you need to remember that this pipe gives you another measurement right here. It's giving you the length, the depth of the pipe, or the width of the pipe, excuse me. So if you know that from the inside, the radius to the inside of the curve is 8, you basically are going to take that one and you're going to add it to the other side. Okay? And what that tells you is that this is going to be 8 and this is going to be 9. And that's going to be your radius. All right, now, but I told you that I needed diameter. So let's go through this real fast, and I'll come over here now just a little bit. Okay, I wrote down 8, but I don't want 8, do I? I need diameter. So 8 is actually, so that diameter is supposed to be 16. All right, now let's go back to this one again. We know that the inside is 8. Add the extra 1 and it gives us to the outside. So from here to the very end, basically if I rewrote it out here on this side, gives me 9. That might help you out a little bit. Well, that's my radius. Well, if my radius is 9, what's my diameter? It's 18. Okay. Well, now what we're going to do is 18 plus 16. 18 plus 16 divide by 2. And that's going to give me 17. That is my inside diameter that I need. Now, if you notice, I kind of messed up again. I'm glad I called it. I wanted you to see this. So make sure you're watching your work. Now, I know I've tried to explain this to the best of my ability because it's cracking, but I'm going to try it one more time. Remember, this is the radius of the inside of the pipe. The inside curve is 8 radius, so I need the diameter. That gives me 16. And since I'm going from 8 and I need to get to the outside, which is an additional 1 centimeter, that makes from this to this 9. So my outside diameter is 18. Add them together and I get 17. Now, this is all right. So far, hopefully you've been able to keep up with me at this point. Notice that the curve is 1/4 of a circle. This curve is 1/4 of a circle. So what we're going to have to do is we got to find the circumference of an entire circle, and then we're going to add divide it by 4. Excuse me. So circumference is pi divided by d. Pi times 4. Let me rewrite that. Pi times 17. This is what happens when you are thinking with half a brain. So this should be, matter of fact, I'm going to scratch this out and write over here. C is equal to pi times D. C is equal to pi times 17. So my circumference is approximately, according to my calculator, and I'll show it to you, 53 point blah blah blah. But the problem told me to round to the nearest tenth as needed. So I'm going to say it's about 53.4. Okay. Now, but here's my problem. It says C is 53.4, but am I done? No, I'm not. I got to remember that curve is only a fourth of a circle. I solved for an entire circle. So I need to divide that by 4. And when I do, I get approximately that curve. So we need to divide by 4, okay? And we get approximately about 13.4. All right, double check my math here. Yeah, 13.4. All right, so the length of that curve, right here, the length of the curve, not the straight pieces, is about 13.4. Now that I know that, I know the length of my straight, the length of this straight, the length of this curve. What do you think I'm going to do to find the length of the entire piece of stock? I am simply going to add. So 12 plus 9 plus 13.4 gives me 34.4 centimeters. Now, I will admit, this is a very tough problem, and the one before it is an extremely tough problem. Please take your time with these. These are 2 test questions. If you are doing your homework and you're skipping these, you're going to get these problems wrong on your test, okay? So you need to take your time with these. And I'll do my best again to talk about this in class to help maybe clear up some issues I couldn't do in the video. All right, we're down to the last question, and I'm very thankful. And this one is not nearly as bad as the other 2 that we just did, okay? I'll explain what this is in just a second, but I want to look at it. It says, what is the cross-sectional area of a cement pipe? What does it mean by cross-sectional? All right, so I got some roll of toilet paper here. All right, if I were to, well, basically, if I cut it in half and I looked at it from the top, this is what a cross-sectional it is. I know this is a roll of toilet paper. I know that it has a length here, okay? I know that there's a diameter for the hole here, and I know that there's an outside diameter, okay? So that's really what this is when I look at, say, a cross-sectional of a pipe, it's like looking down a toilet paper roll, all right? You see the empty spot down here, and you see the edges, okay? And it tells us how thick these edges are, and it tells us how wide the inner circle is, or the diameter of it. All right, so in this particular problem, it told me that I had a cement pipe that's 2 inches thick. So here we go, kind of looking at it this point, from here to here, from this part of the roll to the outside of the toilet paper. That's like 2 inches thick. Okay, I know this is not exact, but I want you to see the point. And then the problem says that the inside diameter, so the actual cardboard tube, would be approximately 2 foot. Now, if this was a real thing done by looking like this measurements are showing, this would be a pretty big piece of toilet paper. Okay, but well, anyway. Those are for, you would need that size toilet paper for a big job, apparently. But I'll leave that alone. I'm not going to go down that and chase that rabbit, because that might get gross. All right, anyway, moving on. So, you know that the inside diameter is 2 foot, and you know that the outside wall is 2 inches. Well, I'm going to go ahead and tell you a little secret about this problem to make your life really easy. Change this dimension into inches, okay? It's going to make your life so much easier. And how do you do that? Well, recall that 1 foot is 12 inches. And since I've got 2 of them, that means that this is 24 inches. All right, so we just made our life easy. Now, what are we going to do to solve this problem? Well, first off, we're trying to find the area. So what we're trying to do is get all of this. And I'm not going to highlight everything because I want you to see some stuff later on. We're going to get all of that. So what does this look like? It looks very reminiscent of the ring problem that we did earlier in the video, where we're going to find the area of the big circle and we're going to subtract the area of the small circle. So let's talk about the area of the big circle. Alright, so you know that the basic equation is pi r squared, but you probably want to know, how did I get this 28? Well, think about it. This inside diameter is 24, but I have an extra 2 inches here and an extra 2 inches here. Well, 2 plus 24 plus 2 gives me 28. So this entire outside diameter is 28 inches. Alright, doing that, I can find my area and I get 2,461.76. And now my job is to find the area of the small circle. Well, I know the area of the small circle and my, wow. Guys, I am sorry. Scratch what I just told you because I did this wrong again. Please forgive me. I'm going to have to redo these videos later on. But look, can you guess what I did wrong? I said that the radius was 28, but look what I really have. I gave you the diameter. So this is correct, but this is wrong. So the radius is really supposed to be what? Supposed to be 14, because I have to find half the diameter. Now when I do that, I'm going to find pi times 14 square, and I get this in my calculator, and I get 615. And I'm going to round. It doesn't tell me to round. I'm just going to go ahead and round to the nearest hundreds. 75. Alright, now, since I know this diameter right here, is 24 inches, that means that my radius should have been 12. So I'm going to plug that in my calculator. I'm going to say pi times 12 square, and that's going to give me 452.39. Now I can subtract them. I'm going to slide this up. I'm going to say 615.75 minus 452.39. And when I do, I get 163.36. And what unit am I in? Inches square. Now again, I apologize for making a mistake, but that's okay. You see that I'm human. Most math teachers won't let you know that, but I will, because I admit it. I'm human. Alright, now, that's it for that video. You have one more video. I will try to post that later this week. I'm hoping my voice will come back and maybe it will be a little bit more professional. I'm sorry that these last two videos have been so squeaky, but I'm hoping that at least you were able to get the important information out of it. Like I told you before, the problems with dealing with length of stock, make sure you don't goof up on those, because those are test questions. It's a big question. Quite frankly, this right here is really important if you are going to be a welder or a pipe fitter or anything like that. It is a very useful equation in helping you do your job. I will tell you that as a fact. It got used a lot when I worked with Robert's company. Maybe not in this format, but it did get used quite often. But that's it for these videos. I apologize again for the squeaky voice. I know you're probably sick of hearing me squeak. So I'm going to shut up now, and hopefully in the next video I'll be a little bit better. Alright, bye.